Hi, everyone. Today is May 20, 2021. Welcome to this week's SIG scheduling meeting. And this meeting is being recorded and will be uploaded to the YouTube channel. All right. So I suppose you can see my screen, right?
Yes.
Okay, cool. Let's go through the agenda. First one is that due to some requirements from the steering committee, we need to clean up our maintenance and reviewers regularly if they are not active for a period. So thanks for Abdullah and Aldo working on that, working on the dev step metrics to come up with a list of inactive members. So we have this to clean up both the approvals and the reviewers. So that give us better chance to get proper person to review the PRs. Okay, that's for your information. Second one is last week we and Dave just introduced idea about adding the extended resource support to the balance allocation plugin. And during the reviewing, both from me and Aldo, we found out that there is some designing flaw in supporting the extended resources on the existing plugins, like least request and the most requested. So basically, the problem we found is that in a heterogeneous environment, which means some machines have this kind of particular resource, but some don't. So for this kind of situations, we are not properly scoring the machines properly. For example, I can give an example like we have 3 nodes and 1 node doesn't have a GPU. So then suppose we come best efforts part, and so this is the current usage among the requested resources and the capacity. So in this case, this part doesn't request any GPU resource, right? But we calculate all the accumulated requested resource and divided by the capacity, so that we got a final score for node 1. For the least requested will be the highest, and second one will be node 2, and node 3 will be the lowest score. So this sort of doesn't quite make sense, because the GPU resources are the scarce resources, right? If a node doesn't request that, and in this case, you can see there is a tie in other resources. So probably it makes more sense to choose node 3, so that we don't interrupt this kind of scarce resources, right? So, but this is not the current behavior. So we want to sort of get a consensus on how and if we should improve this. And you can leave any opinion on these issues. And after we get to a consensus, say, okay, we need to adjust these algorithms. Then we can go to the algorithm details, like what kind of algorithm we should to make a better favorites on the nodes. So basically, yeah, there's some discussion on which kind of algorithm we should choose. Yeah, and also I mentioned DRF. Maybe we can leverage the DRF algorithm to ensure the resource fairness. So this is for the issue and the reviewing of the balance allocation, adding the extended resource support on this. So I think we may need to resolve this first if it doesn't take a long time, and then block this issue, because the problem exists in the extended resource support, and also this proposal is intended to adding the extended resource support. So basically, kind of depend on this. So
one quick comment here is that
yeah.
like I agree that maybe we should improve it.
Mhm.
But typically you wouldn't want to schedule a pod that doesn't request a GPU on a GPU node in the first place, because it's a
Yes,
waste of.
correct. Yeah, this is
So
for the scoring. Yeah.
Usually, like for example, on GKE, what we do is that you have a taint on these nodes by default, and only if you tolerate these nodes, which is typically a pod that requests a GPU, the pod will get scheduled there. But the general point, I think, is still valid. Like, we need to take care of this in a probably better way. But I don't think it's as problematic as you might think.
Okay. Okay. Sounds good. Yeah. So that means in the user's perspective, they need to take care of the taint and toleration setup to ensure not to waste the resources on the machines which has the scarce resources, right?
Right. Ideally, those scarce resources are expensive. You don't want to actually, hog them for pods that don't want to use them in the first place. So a filter here is probably better in general, not just like a preference.
Yeah, agree. Yeah. Any opinions? Please visit these issues to leave your comments. Next item is raised by Abdullah, a single scoring plugin for node resources. The background is that we have a couple of scoring plugins which should be enabled exclusively because they work in sort of in the opposite direction, like the least allocated versus the most allocated. So we want to introduce a single plugin as the scoring plugins and make those kind of behavior as the options in the form of the plugin arguments. So Abdullah proposed that we can use the existing no resource fit. This is right now is the filter plugin. So, but we can make it a variant of the score plugin as well, so that we make least allocated, most allocated, as well as others as plugin arguments. So because this is good, but we need also support the Viva Beta 1, which is use the scoring plugins as is. So once we migrate to Viva Beta 2, once we have the unified resource fit plugin as a scoring plugin, we may need to handle the conversion as well as some other things. So thanks to Abdullah to do a breakdown on the issues so we can get this kind of items one by one. So right now, the first items is being working on, and the other items, Abdullah, do you want to take it over, or do you want to be more volunteers?
You can read on the issue, but I think one important thing here is that we can remove the algorithm provider and the algorithm provider flag completely. I double checked with Jordan. I think it's safe to remove the flag, the command line flag, because the default set of plugins right now is being set outside the defaulting logic for component config. That's kind of problematic. Like, we want it to be versioned, and if we want it to be versioned, it needs to be set in proper. Like, if we want it to be properly versioned, we need to set the default set of plugins in the defaulting logic, so that in V1 Beta 1, for example, we don't change the behavior. We continue to use least allocated. In V1 Beta 2, we change the behavior. We can change the defaulting behavior by changing the set of default plugins and replace least allocated with this new plugin, with the default still being like the same semantics, but it's a different plugin. This is important because if you remember, like, you could disable and enable plugins, right? So disabling plugins, you disable them for the default one. So if, for example, a provider disables least allocated, and least allocated is not part of the default set, it's going to break their like their setup. And so we want a way for them to do it properly, and the proper way is to say, if you are using v1 beta 1, then you can disable least allocated because it exists. But if you are in v1 beta 2, you don't disable it. You can change the configuration, right, for the default plugin that already exists, which is the fit. And so I create another issue to remove the algorithm provider, and that will, I think it's a good cleanup. It will move things towards really making all the defaulting logic for the scheduler more and more as part of component config. We had Aldo working on the plugin configurations a while ago. Now this is the set of plugins themselves. I think that they should move there as well.
Yeah, makes sense. So do you want to move it a little bit ahead of other items for this one?
I think it doesn't matter. At the end of the day, we need to do everything in the cycle. I think we have time.
Okay, okay. Okay, thanks, Abdullah, for working on this. Next item is from Tyler. Do you want to take over to give some demo and introduction on the scoring plugin proposal on the topology aware scheduler? I can make you.
Yes, please. Can you hear me?
Yeah, I can hear you, but there's
Great.
okay. Noise.
I will try to put the mic far away a bit. Now it's better?
Yeah, it's better.
Yeah, it's better.
So yeah, I'm gonna start my sharing. So you can take over to share.
Okay, great. Let me share my screen very quickly.
Yeah, I can see your screen.
Great. Just a second. Okay, so hi everyone. My name is Talor, and I'm a team member of the Echo Engineering team at Red Hat. So as part of our ongoing effort to improve the way Kubernetes handles latency sensitive workloads, I'm going to introduce you to the proposal for a NUMA aware score plugin. This proposal is an extension of the node resource topology filter plugin, which introduced here in the past by my colleagues Swati and Alexi. Okay, so this is today's agenda, and with no further ado, let me jump into the motivation section. So currently, node resource topology filter plugin, its purpose is to filter out nodes that can't address the pods request on nodes which are configured with a single NUMA node policy. So topology or scheduler as a whole aims to take the advantage of the NUMA awareness in order to make more optimal scheduling decisions. So we would like to take it to the next step and enhance the filter plugin with a score plugin, which is also NUMA aware, in order to determine the best candidate amongst the list of nodes which provided us by the filter plugin. So basically, the filter plugin was created in order to avoid from topology affinity error caused by the kubelet. And the score plugin intended to decrease the chances of pods stuck in pending state. So both of those errors occurs due to the fact that there is a gap between how the Kubernetes scheduler and the kubelet sees the hardware topology. Basically, kubelet has more knowledge and more information about how the node resources are spread among NUMA nodes, and Kubernetes scheduler doesn't. So we would like to add this scope plugin, which has NUMA awareness ability in order to reduce these gaps. And eventually we will end up with less issues, as I mentioned, with less issues, as I mentioned before, the pods stuck in pending state. And on the long term, it will allow more optimal utilization of the system resources. Any questions so far? Okay, I'll take that
Not
as
quite.
a no.
I just want to give a background is that the topology aware plugin support has been available in the scheduled plugins. So in the background, we pursued to add this support in the upstream, but due to the no resource API is not mature and served as a CRD, so it against the community rules to adding a CRD support in the upstream. So we use the scheduler plugin as a place to incubate this kind of plugin, and also the no resource API has its own repo to evolve over time. So yeah, this is a little background.
Okay, thank you. So this scope plugin offers 3 different strategies for score calculation, which are basically an imitation of the already existing in-tree Kubernetes plugins. So we have the least allocatable strategy, which is basically a way to we are trying to bin pack as much pods as possible on a given node. We have the balanced allocation, which is kind of like spread the resource allocations as evenly as possible across all available nodes. And we have the most allocated, which is the opposite to least allocatable. So it will look for the nodes which has the most amount of available resources and try to deploy the pod there. So this is an example for the kind of problems that the new score plugin intended to solve. So we're going to very quickly, I'll try to provide here a comparison between 2 plugins, which has the same logic, but one of them is non-NUMA aware and the other does. So there is the Kubernetes in-tree most allocated scope plugin, which try to bin pack as much pods request as possible on a given node. And we have the new scope plugin configured with the least allocated strategy. So they both try to bin pack as much resource, as much pods request as possible on a given node. So this is the current cluster. We have here 2 hosts with 2 NUMA nodes each. One has 4 cores on each NUMA, and the other one has 2 cores on each NUMA. The brown cores are reserved cores, and the blue ones are available for allocations. And we have here a set of 3 requests, 3 pods, which are requests to be deployed on the current cluster. Here I attached a link to a live demo, but due to time constraint, I won't present it right now. So I'll just run very quickly on the problem itself, and later on, guys, you can take a look and see it on a real environment. So, as I said, scenario 1 with the in-tree most allocated scope plugin, we try to deploy pod number 1 Oh, one other important thing to mention here is that both nodes are configured with single NUMA node policy. So to the people here who doesn't know what single NUMA node policy is means that the pod will be accepted only if we have all the CPUs that it asks for are coming from the same NUMA. So this is an example for, this is a good example for a pod that can be accepted because all cores, as you can see here, are coming on the same NUMA. So the first pod will ask for three cores and it will be deployed successfully. The second pod will ask for 2 CPUs. And again, as I mentioned, we are trying to bin pack. So this scope plugin will decide to deploy it on host number 1. And now we had pod number 3, which asks for 3 cores. But as you can see, we don't have here an available host with 3 cores which are located on the same NUMA. Okay, so this pod will stack on a pending state. So let's go back and try to do the same with the new scope plugin. So again, the same setup, the same cluster, everything remained the same. We just replaced the, we configured the pod to ask to be deployed with this scheduler. So request number 1 is exactly the same, pod 1, 3 CPUs on host 1 NUMA node 0. Then here comes the key difference. Pod number 2 will be deployed on host number 2 because since this plugin is NUMA aware, it says that it's better to take 2 cores out of 2 available at the NUMA level than take 2 core out of 3 available at the NUMA level. So this is kind of more fitting than at host 1 NUMA 1. And of course, the third request will eventually, it will eventually manage to successfully deploy it as well. So that's basically the explanation of the problem. I will, since I don't have much time, I will skip on the algorithm itself, and I'll just give you a quick look at the manifest, how it looks like. So this is a standard kube scheduler configuration manifest. We can enable the plugin here. So we have score enabled here, and one important key to mention here is that we have this field which calls score scheduling strategy. So the user can switch between different strategies by his choice. And basically I'm done. If you have any questions.
Could you go back to the algorithm page? I have a question.
Yeah.
Yeah, so you mentioned that you will do the scoring per NUMA node, right? So I suppose you mean that in the scoring, in the final normalized scoring, you will, for example, for the node 1 you just mentioned, there's 2 candidates, 2 NUMA nodes candidates. So you will choose the highest score for the NUMA node, or do you do a aggregation on the 2 NUMA nodes there?
You are asking how do we decide the final score for the node? That's the question?
Yeah, correct.
Okay, so basically, assuming we have 2 NUMA nodes, as you said, we will score each one of them independently, and we will return the NUMA node with the minimal score as the node's final score. We won't calculate them together or something like that.
Okay,
and that
makes sense.
And that's because we would like to avoid from a worst case scenario and stuff like that.
Okay, that makes sense. So another question is, how do you ensure this kind of Newman node is the decision is consistent with the kubelet topology manager's algorithm? Because, for example, for the node one, you have, yes, we do assign the node one to the spec name, but when it comes to the kubelet execution, it also has two choices there, right? So how can we ensure the result is consistent?
You
Yeah,
mean,
I can
yes,
take that. We actually, the filter plugin that we have is almost a simplified version of the topology manager logic. So it does consider how alignment would happen from resource point of view on a NUMA node.
Hmm.
And then the scoring plugin essentially scores the NUMA nodes, essentially the nodes based on the NUMA nodes and the resources that have been requested. And that's how this, and eventually you'll obviously select the node which has the maximum score.
Okay, yeah.
So when you score the whole node, right? Like not a specific route or
Right. Yeah, you score the whole node, but you consider scores corresponding to NUMA nodes and then aggregate them to identify the score corresponding to a node.
right. But the question is, like, once the scheduler made that decision and set the node name to that node, is there an agent on the node that actually going to place the pod on the right route or the right NUMA?
Got it.
Assume that you have two that would fit the.
So yeah, like that is a gap that is essentially known right now, because there's no way for scheduler to convey exactly what NOVA node the resources would be allocated from. Like topology manager still executes its same logic, so it is kind of a best effort that topology manager would make the same decision as the scheduler would make, but there could be a scenario where the decision is kind of different from what the scheduler has evaluated.
Yeah, and another potential risk is that you have to ensure that the policy in both kubelet and the scheduler are consistent. Like you are specifying a list allocated in the schedule side. Meanwhile, maybe you are specify the most allocated in the kubelet topology manager side. So that will also cause unexpected behavior. Yeah, that's
but
also
kubelet
one.
does not have any policy. Like how would
Yeah,
we?
yeah, but you should have, right? Otherwise, you just randomly pick up the available NUMA slot there.
Yeah. So we probably need some sort of alignment between the strategies and the policies that are configured at a scheduler level and at a node level, which is currently not known. So I guess one thing we could do is like identify, like obviously these are good points. We were planning that we'd submit a proposal to the scheduler plugin repo and capture them as kind of known items and try to figure out what are the possible solutions of addressing those. Does that sound good?
Yeah, another option can be that we made sort of an interface to let the kubelet aware of the specific NUMA node we want to assign to, not the high level node name, but specific NUMA node. So that we don't need to worry about what kind of configuration policy is defined in the kubelet side. It just
that was an idea. That was an idea actually that circulated, I think, very early days of topology aware scheduling, when we discussed some sort of a hint coming from the scheduler to kubelet. And
because why we can fix this problem is that we want to ensure that the eventual execution result is aligned with the scheduling result, right? If there is no consistency, there's no point bringing up a new scheduling scoring plugin to do a lot of extra calculations, right?
Yeah, that's a good point. So where would you see like this kind of hint? Like obviously scheduler is doing its evaluation, and we could figure out a way, maybe adding an annotation in the pod spec or something like that for the kubelet to consider, or an agent to consider to maybe act as a hint provider? I think that those are kubelet changes, I guess.
Yeah, annotation is one solution, but I think the community is not a fan of that, right?
Yeah.
Yeah, so yeah, we can come up with some documents to listing all the potential options. Yeah,
Cool.
for the
Yeah.
discussion. Yeah.
Cool.
Sorry,
Yeah, so that sounds good.
what would be the main reason why you want to do this in the scheduling plugins and not directly in upstream? Because I think there is already a cap or already some implementation about NUMA.
Yeah,
in
that was
Node.
actually me. I had proposed the cap as well as like the implementation upstream, but I think we mentioned it initially. The gap was that the CRD API itself is not mature yet, and that's why we moved towards scheduler plugin to be able to gain some kind of attention and for allow people to use it there, and then eventually we move towards an in-tree plugin.
And what is missing? I think I would rather like to see the CRD maturing.
Yeah. So the CRD exists, and um, and I think like I want to clarify if that is the question for the filter plugin that was proposed previously or the scoring plugin that Talor just presented.
Oh, I see.
Yeah,
So we
Aldo.
already.
So
Yeah, they're
yeah,
kind of
Aldo.
slightly separate. Yeah, linked but separate.
Yeah, Aldo. The background is that it was firstly pursued to get this down in the upstream, but because the plugin depends on the CRD and CRDs, we don't usually adding direct CRD dependency in the core Kubernetes repo, right?
Correct.
So we got a lot of pushback on getting implemented in the upstream. So I think once we got the node resource API mature, and we can get that incorporated in the core APIs, then we can move the topology up with plugin to upstream.
Is that being pursued already? How are those communications?
Yeah, so kind of they are related, and basically I'm the owner of this piece of work. So it's me. I was initially working on in-tree enablement, then started working on out-of-tree enablement. And once things are kind of at a reasonable state and we have people who are using it and maybe we get some more feedback on the CRD API and we think it's in a reasonable state, we'll again go back to having those conversations with essentially SIG architecture, SIG nodes, SIG scheduling, everyone.
I see. Okay. All right. I don't have any more concerns for now.
Cool. Thanks.
But I would suggest you continue pursuing the graduation of the CRD into an API, and so definitely involves SIG scheduling when you do that. Even if it's only node related, I think it's better for us to be involved from the beginning.
Totally. Like you can have a look at the current state, like how it looks like at the moment. I did open in the staging repo, in the staging section in Kubernetes as well. But then I didn't want to kind of bypass everyone agreeing on how the API looks like. So yeah, just have a look and maybe give us some feedback if there are things that you think should be done differently or anything that needs to change.
Sounds good. Could you include the link to the upstream discussions in the notes?
I will.
Thank you.
Okay, so I think just to wrap this up, I would like to make sure that we are all on the same page. We were thinking that for the time being, given that the scheduler plugin is in the topology aware scheduler plugin is in the scheduler plugin repo, is it okay to go ahead and maybe create a separate cap and push an implementation PR to the scheduler plugin for this change?
I think we should firstly raise the cap to the Kubernetes repo to focus. That cap will focus on the kubelet policy support first.
Okay.
So basically, we have two options. One is to make the decision dispatched by scheduler. So I mean, the human decision aware of Kubernetes. That is one option. The other option is that to add the policy, scoring policies about the Kubernetes, which should be consistent in the later we introduce the scoring plugin in the scheduler side. So that is one. That's my suggestion to respect CAP in the Kubernetes and involve the scheduling and the signal. So the second CAP can be just an update on the existing topology aware plugin CAP in the scheduling plugin repo. Yeah.
That sounds good. Okay. Okay, so that sounds like a good direction. We'll follow up on that then. And Wei, I'll keep you in the loop as we go along,
Sure,
and maybe
thank
we
you.
can work on a proposal for the hint and hint calculation between kubelet and scheduler.
Yeah, thank you.
Cool. Thanks, everyone.
All right.
Okay, thank you.
Yeah, Taylor, you can stop sharing. I can finish the last piece of the page agenda. Yes, thank you. Yeah, sorry we run out of time. So basically, the last item I want to mention is that there is some backlog issues. Some are working in progress, and some need some help. So if you have time and want to dive into the code to fix some bugs, this is some good candidates. So it's not a good fit for the first-time contributors, so it does need some understanding on the soft skills. So yeah, that's it. And before we end today's meeting, anyone has any questions? Please raise up. Okay, otherwise I will